All right, so 4.5, definite integrals using substitution. So we are going to apply the stuff that you guys have learned about with finding integrals using substitution. We're going to apply it to a definite integral. So I'm going to show you with an example. I have a little added bonus step to it. And when I say bonus, you guys are probably laughing at me, but it really is a bonus step because I think it's going to make your life a little bit easier. So let's start with this example. This is actually the only example I have for you. You are going from 0 to 1. You're so lucky it's your birthday today. X times x squared plus 1 to the power of 3 dx. So what am I going to do with u?
X squared plus 1.
Okay. U is equal to x squared plus 1, which of course then means that du is equal to what?
2x.
2x dx. So, I want to tell you something right now. You could go through this like normal, and then take these values, 0 and 1, plug them into your integral, subtract your answers, and you have and you're done. That's going to be your area underneath this curve. But I'm going to make it a little bit easier for you and show you a little trick. If you take this 1 and this 0 and you plug it into this, in for these x's over here, because remember this is you are trying to find the area of this function from 0 to 1, but this function is written in terms of x's. So if you take these ends and you plug them into here and you find the value of the x's in terms of u's, then you don't have to take that extra step at the end. You know when you do your integral in terms of u's, and then you replace the u's back with whatever it is that you call u? You don't have to do that anymore. You're going to save yourself a little bit of work. So for those of you that are going, I don't know what you just said, hold on and you will see what I mean in just a minute. So let's take this 1 and this 0 and plug it in for this x over here. So we're going to do a rewrite of this integral. We're not going to go from 0 to 1 anymore. When I plug a 0 in for this x squared plus 1, what is 0 squared plus 1?
1.
It is 1. So we're actually finding the integral from 1 to, if I put a 1 in for this x squared, what is 1 squared?
1.
Plus 1 is 2. So now this integral will get you exactly the same answer as the original because you have switched this 0 and 1 to be 1 and 2 because that 0 and 1 in terms of u is 1 and 2. So one extra step. You need to plug in those x's into this u equation, get an answer, find the integral like normal. Let's do a rewrite here. We have an x and a dx. Well, over here, we have an x and a dx also, but there's a 2 in front, so what do?
Divide by 2.
Divide by 2. So I divide this side by 2, I divide this side by 2. So x dx is really what? du divided by 2. What about x squared plus 1 to the third power? This part right here, we're going to do a rewrite so that it is
u cubed.
I'm going to do another quick rewrite from 1 to 2 of u cubed over 2 du. I think it just looks a little nicer this way. Find the integral. What is the integral? What do I do to the third power?
I add a power.
Make it a power, make it 1 more power. So I have u to the 4th divided by 2 divided by 4. 4. All right, now well, let's take it one step further. What is u to the 4th divided by 2 divided by 4? Yeah, you remember how you have to multiply by the reciprocal, they cancel out, you multiply by 1/4 in the numerator. So you end up with u to the 4th divided by 8. Now for those of you that are confused by this process, what you're really doing is taking a half and you're dividing it into 4 parts. So it's 0.5 divided by 4. That's the same thing as 1/8. So you have 1/8 u to the 4th. And remember when you're finding a definite integral, you do this thing over here on the side, noting to yourself that you have found the integral. What do I put over here? What goes in the bottom?
1.
1 What goes on the top? A 2. So we are finding now the value of this thing from 1 to 2. We used to go back now and we would replace this u with x squared plus 1. We don't have to do that anymore. Now you literally type, you put a 2 in there, you put a 1 in there, and you evaluate it and subtract your answers. So we're going to do 2 to the 4th power over 8 minus 1 to the 4th power over 8. Okay, what is 2 to the 4th power? 16 divided by 8 is 2. 1 to the 4th power is 1 over 8. So we have 2 minus 1/8. What is 2 minus 1/8?
15 over 8.
You end up with 15 over 8. So, had we went back and plugged in, replaced that u with an x squared plus 1, and we would have stuck with our original boundaries of 0 and 1, we would have gotten exactly the same answer. So if you prefer to not do this extra step where you change these x's into u's, you don't have to do that. That's a choice. Yes?
On the test, you know how like you taught us one thing, then you added a step, and then you taught us something else, and then you added a step. How do you know when to do the one with the step? You get what I mean?
I get what you mean, but I think that based on the directions, it will be, you are supposed to know what you're supposed to do.
Like, if you were to ask us a question, what would the
If
direction be?
I were to ask you right now, on the test, if I were to say, find the area of this curve, you don't have to do it the other way, the way that I have showed you before. You can use this way if you want to. But just know that the other way is acceptable also, okay? If I ask you for an indefinite integral, what do you know you always have to attach to the end? You have to have a plus c at the end. If I ask you for a definite integral, you don't need to, because remember those c values wipe each other out when you subtract them anyway. So you do not need to include those. Okay? Alright.
So we can basically use whatever method we